Hello, my dear students. I hope you're all doing well. My name is Benatang Patong, and I welcome you all to the channel Classroom, where we learn together. So, today, my dear students, we will be learning about a very important topic, and this is very important. I cannot overemphasize on this one. This is very important. Without this, you will not be able to do the numericals, because in this lesson we have numericals, and then numericals. In the exam, in the final board exam, there will always be a numerical question. If you have the text, if you have the previous year question with you, pause the video, go and check the question paper and see. You will find one question from light chapter which carries 3 marks. So this topic will help you grab the 3 marks, which is going to help you, okay, which is going to help you achieve the desired mark which you want to score in science. So you want to score 100 out of 100, you can. Okay, my dear students, you can. Believe in yourself. You want to score whatever amount of mark you want to score. You want to score 99, you want to score 98, you want to score 100 out of 100, you can. But the first thing is, you have to believe in yourself first and put effort. So in this video, I will help you, okay, fight and grab the 3 marks, which will help you, which will push you further to achieve your marks, which will help you achieve your the mark which you want to score in science. Okay, so this video is going to be very helpful for each and every one of you, especially for those students who wants to do numericals which are there in this chapter. And this lesson numericals, okay, the numericals from this chapter light is very easy. So this is the class which you should not miss. Okay, this is the video which you should not miss if you want to really learn how to do numericals. So enough talking, let's go to the topic and let's start learning. Okay, so like I say every time, my tool is here. Where is your tool? Where is your tool? Yes, those who are tuning in, you know what I'm asking for. So your tool is a notebook, a pen or a pencil, and to write down whatever we discuss here. Okay, so let's start. Sign convention for mirrors. In this topic, we are going to discuss so many things, and each of these are very important. Okay, so to start with, let us draw a ray diagram. So on this side, I'll be drawing a ray diagram. You also draw this ray diagram in your notebook. So let us draw a mirror. So yes, let this be the mirror. Now, this is a concave mirror. I have drawn a concave mirror, but I will not be marking the back side or the front side. Okay, let's just draw it like that. Okay, this is a concave mirror. If you ask me, this is a concave mirror. Then let me mark the pole, very important. So this is the pole. I'm going to make it bigger. I'm going to write the letter B, P also bigger, okay? Then a line which passes through the pole is called the what axis? Correct, principal axis. So let's draw the principal axis which passes through the pole. Now, at the same time, okay, I have drawn this very high. I have to make some room here. Okay, this will do it. So now here, I'm going to draw a very important figure here, okay? And this figure is called the direction of light. Now remember, my dear student, this is the mirror, and then this is the left side of the mirror, and this area becomes the right side of the mirror. So from where are we saying left side and right side? We are saying left side and right side from the pole. So from the pole, this is your left side. From the pole, this area is your right side. So we have left side and right side. Clear? All right. Now, remember, object is always kept in front of the mirror. Let me write down this. So, important points, okay? So, important points. Important points you have to know. So, point number 1. Object is always kept in front of the mirror. In front of the mirror. Kindly write down this point, okay? Because afterwards I'll be erasing this point. I will not be erasing the diagram. We will be using it till the end, but these points I'll be erasing because there is less space, okay? So point number 1, object is always kept in front of the mirror, which means that the object will always be here, okay? In front of the mirror, or we can also write left side, okay? On the left side. Left side. So I mean to say that object will be kept here. Okay, anywhere, okay, anywhere here, anywhere you can keep it. Okay, object will always be kept on the left side of the mirror or in front of the mirror. Remember, my dear student, this is the mirror. So if I keep it here, the object is in front of the mirror. Clear? Okay. Now, also remember this, that light first falls on the object, then the mirror. So light first falls on the object, after which it falls on the mirror. So the object is kept here. Then, where will light fall first? Light will first fall on the object, then it will fall on the mirror. Remember this. So next point, light will first fall on the mirror. Now, with the help of this statement, I will be drawing the direction of light. So let me show you the direction of light. Since light will first fall on the object, so let me show you the direction of light. Okay, time for me to draw the object. So let me draw the object. Let's say this is the object. Okay, this is the object. So this is the object. O, B, J, E, C, D. Okay, this object. And then light will first fall on the object. So let me show you the light. So the light will be this. So this is the direction of light. This is very important. We study sign Cartesian with respect to the direction of light. Okay, so very, very important. Remember, light first falls on the object, therefore the source of light is from here. Okay, light ray travels from here. So my hand, my 5 fingers, this is light. So light first falls on the object, then it will fall on the mirror, and then okay, it will continue its path off the screen, right? So remember, the direction of light is like this, my dear students. I hope it's clear. All right. Now, next, yes, another very important thing. Remember, every measurement starts from the pole. All measurements starts from the pole. Okay, so all measurements starts from pole. So remember, okay, points. These are all important points. Important points. All measurements start from pole. Very important. Every measurement starts from pole. What does it mean? It means that we will start our measurement from here. Okay, so we will always start from here. To measure anything, we start from here. So let's start the measurement. So now we will discuss about the measurements. Now, what are we measuring? What are we measuring? We have so many things to measure. Number one, first we have to measure the object distance, like how far is the object from the mirror. Okay, now remember here, measurement will start from the pole. So we will be measuring how far is the object from the pole of the mirror. Understood? Then we will measure image distance. Let's say the image, let me also show you the image. So let's say the image is here. Okay, let's say the image is here. And let us also draw one more image here. Because in mirror, we have virtual image, which is from behind the mirror. We have real images, which are formed on the same side of the object. Okay, real images are inverted. So this is a real image, and virtual images are, yes, erect. Okay, this is an erect image, so this is a virtual image. All right. Now, all measurements start from pole. So now time to start measuring. Remember, okay, measurements done along the left. Okay, measurements done along the left. Okay, measurements done along. Okay, measurements done. Let me rephrase it. Measurements done along the direction of light will be taken as positive, and measurements done along measurements done opposite to the direction of light, which means along left. All right. So I'll repeat again. Measurements done along the direction of light. So remember, we are measuring. We will be here. All measurements starts from pole. So I'm here. So let this be me. Let this marker be me. So I'm always here. Measurement from here. Measurements done along the direction of light. Along the direction of light. That means I will be moving like this. Am I not moving along the direction of light? Look at the direction of light. Direction of light is like this. Okay, light is traveling like this. Let me show you again, and it will exit the screen. Understood? So I'm here because every measurement starts from pole. So measurements done along the direction of light. So am I moving along the direction of light? Yes. Now I'm out of the screen. So measurements done along the direction of light are considered positive. Let's write down this. So measurements done along the direction of light are taken positive, which means plus, and then measurements done opposite the direction of light, are taken negative. All right. So measurements done along the direction of light are taken positive, and now I'm here again because every measurement we start from the pole. Measurements done opposite to the direction of light. See, my movement is opposite to the direction of light, is not. So measurements done opposite to the direction of light are considered as, or are taken as, negative. Okay, so make sure that you're writing this one. Now let us let us find out what we are measuring. So I think I can write here. So let me write here. Okay, now what are we measuring? First thing, we will be measuring object distance. Object distance means how far is the object from the pole of the mirror. So object distance, remember this is the object. Okay, and this is one of the images. So this is the image, one of the image, and this also is an image. Now object distance means how far is the object from the pole of the mirror. This is the object, this is the pole. So how far is the object from the pole of the mirror? This is called object distance. And what symbol do we use to represent the object distance? Remember, my dear students, object distance is represented by the small letter u, lowercase u. Lowercase u. Okay, so u is equal to object distance. U is used for representing object distance. Now remember this, my dear students, object distance. Now okay, before I tell you that, while measuring object distance, from where do we start? We start from here, isn't it? So to measure the object distance, I go like this, I move like this. Check out my direction of movement with respect to the direction of light. Am I moving along or opposite? I'm moving opposite, isn't it? So remember, what sign will I get? I'll get negative. Okay, I'll get negative. Remember, I'll get negative. So I'll be getting negative. One quick way to remember, okay, is that object distance will always be negative. You know why? Because object is always kept in front of the mirror. So remember, universally by default, object will always be negative. So you will be getting object distance, okay, always negative. So u is equal to object distance, bracket, right? Always negative. And the reason is very clear, is because object will always be kept in front of the mirror. So while measuring, we will be moving opposite the direction of light, therefore it will be always negative. Okay, so remember, object distance u, and then it will be negative. Okay, next we'll discuss the image distance. Now before that, let us also discuss about, okay, let's talk about image distance. So image distance means the distance of the image from the pole of the mirror. So here, so let me write here. Okay, so we're talking about this one. So this one, image distance means how far is the image from the pole of the mirror. So which symbol do we use to represent image distance? We use symbol v, small letter v, which is lowercase v. So we draw like this. All right, a little stylish. Okay, not just normal v, but like this. Okay, so that's how I do. So small letter v. So v, I hope it's visible. So v is equal to image distance. Image distance. Now, will image be also always negative like the object? Anyone? Will the image be also always negative like the object? What is your answer? Is it yes or no? It's no. Okay, no, it is no. Now let me show you why it is no. Look, we'll first consider this image. So this image, remember we have one more image here. Okay, so yes, remember, let me show you. From here till here also it will be image distance. Okay, so this also is image. So now, so the distance of the image from the pole of the mirror will be image distance only. The distance of the image from the pole of the mirror is called image distance. So this image, let's measure this image. So to measure this image, I start my journey from the pole and I'm moving like this. Check out my direction of movement. Am I moving along or opposite? Yes, I'm moving opposite as well. So this image distance will be negative. Understood? This image distance will be negative. Clear? Now I want you to tell me. Very easy. You can tell me. What about this? Will this image distance, will it be positive or negative? Correct. It will be positive. Let's confirm it. How? We will be starting from here. Light is traveling like this. I will be, image is here, so I will also move like this. So check out my movement with the direction of light. I'm moving along. Measurements done along the direction of light are positive. So this is positive. Clear? Easy, isn't it? Very easy. Now next one, f. Okay, f, focal length. Now let's measure focal length. Okay, focal length. So focal length, let me just put it here. Let's say this is f. Okay, let's say this is f. So this is f. Let's say f. This is f. So focal length. So this is f. So if I have to measure this focal length, how will I measure? Simple. It will be the distance. It will be the distance of focus with respect to the pole of the mirror. So this will be focal length, and focal length is represented by f. Okay, so focal length, this is point f, and focal length is also represented by f. So f is for focal length. So let me just write here, f is equal to focal length. Now remember, even focal length will be positive or negative. Focal length can also be positive. Focal length can also be negative. How? Very simple. Okay, very simple. I will tell you in a simple way. Remember, if the image is negative, focal length is negative. If the image is positive, focal length is positive. There is no need to study any complex formula here. There is no complex principle here. Simple. Just follow the image. If the image is positive, focus is also positive. If the image is negative, focus will also be negative. So what I usually tell my students is that focus follows the image. So all you have to know is where is the image from, or what is the sign of the image. If the image is negative, then focus will also be negative. If the image is positive, focus for that question will also be positive. I hope that's clear. Okay, so focus can be positive or negative depending on the image. So we have this focus here. Let me draw another focus here. Let's say this is also focus. Let's say this focus. So this focus, okay, this focus is for this image, okay, and this focus is for this image. So what will be the sign for this focus? Check out the image sign. Is it positive or negative? Negative. So this will also be negative. Confirm it. Let's confirm it. Okay. You don't believe me? Let's confirm. To measure this focal length, I'll start from my journey from here now. So I'll be moving in this direction, which is opposite. So it will be negative. See? Nah? Then this focus is for this image. So will it be positive or negative? It will be positive. Why? Because image is positive. Image is positive, so it will be positive. Do you believe me or should I confirm it? All right, you could believe me, nah? Okay, so you believe me, isn't it? See? Yeah, nah? Positive. Okay. So you have to, okay, you have to understand it. Do not memorize it, okay? Understand it. It's so easy, okay? So this is the U, V, and F. Okay. Now let me quickly erase this. So I hope you have all taken this down. If you have not taken this down, let me go to the side. You pause the video and then you copy down. All right. Assuming that you have done it, let me erase this and let us continue the discussion. So this is the most difficult part about using the whiteboard to erase it. I'm using cloth because my dusters are all sticky and they are smeared with this black stuff. I have to wash them. See, they become black. Okay, this has got stuck in my dusters, so I can't use them. So this is the disadvantage of using a marker ink. Now, yes, so using u, which is object distance, v, which is image distance, and f, we get one formula which is called the mirror formula. So with the help of those three, let me introduce to you the mirror formula. So remember mirror formula, okay, mirror formula, which is 1 by v plus 1 by u is equal to 1 by f. All right, so very important formula, very important mirror formula. We will be using this formula when we are doing numericals. Okay, now let's go to let's talk about the height or size. So we move ahead, and now we will talk about height or size. Kiska size, kiska height. We will be talking about the height of the object and the height of the image, height of the object, size of the object, size of the image. All right, height and size are synonymous. Don't get confused. They are the same thing. Okay, so height of the object, height of the image, size of the image, same. Height, size, height, size. This is the object marker. We can call it the size of the marker or the height of the marker. Same. Okay. So remember, for height above principal axis, let me just write like this. Height above principal axis are taken as positive. Height below principal axis are taken negative. It's squeaking a lot. Let me change my marker. So height above principal axis are taken positive means what? See, this is the principal axis. Remember, this is the principal axis. This line is the principal axis which passes through F, which passes through pole. Okay, so this line, above this line, okay, whatever is above this line, okay, above this line, the size or the height above the principal axis is considered positive. Then below this line, the height or the size is considered negative. Very simple. So let's start with this object. Now the object will always be kept above the principal axis universally. Okay, object is never kept below the principal axis. We don't keep object like that. Object is always kept above the principal axis. So the height or the size will be positive. Okay, so this will be positive. All right, this will be positive. This will be positive. Positive height. Understood? This will be positive height. Let me just write positive here. It will be positive. Now let's go to this. This is an image. Check out this image. Is it above the principal axis or below the principal axis? It is above the principal axis. So what will be its value? What will be its sign? Plus or minus? Plus, because it is above the principal axis. So this will also be plus. Positive. Okay, positive. Then let's come back. Let's come to this one. This is the image. Is this above the principal axis or below the principal axis? It is below the principal axis. Height below the principal axis are taken as negative. So this will be negative. I hope that's clear. Above the principal axis positive, below the principal axis negative. This is for height. This is for size. All right. Now then remember this, that height of the image and height of the object you have to know. So when we're discussing about height or size, remember HO is used for representing object height. Okay, let me just write object height here. So HO is for object height, and then HI is for image height. remember this. HO is used to represent the height of the object. So this is HO. You can write HO. HO is for representing the height of the object, and HI is the representation for image. Is for height of the image. So HI. So this will also be HI. Okay. So the size of the image is represented by HI. H for height. Okay. HO means height of the object. O for object. H for height. I means image. I for image. I hope that's clear. Okay. Now, with this, we will go to the next topic, which is magnification. So, all right, we can use this space. So let's go to magnification now. So what is magnification? Very important. This is a very important topic. So what is magnification? My dear students, magnification simply is the ratio of the height of the image to the height of the object. Since ratio is used, there will be a division. Okay, so ratio means division. So it is the ratio of the height of the image to the height of the object. So let's write down magnification. Okay, it is the ratio of the height of the image, or we can write size of the image. Ratio of the height of the image. Okay, let's just write it. Ratio. It is a ratio of the height of the image. Height of the image to the height of the object. You can also write size of the image divided by size of the object. Okay, height and size the same. It is the ratio of the height of the image to the height of the object. Means what? So remember, magnification is represented by M. So as per the definition, it will be HI divided by HO. All right. So magnification is the ratio of the height of the image to the height of the object. Okay. So this is one of the formula for magnification. But there's another formula for magnification. And then for that, we are not going to write the definition. If you are going to write the definition for magnification, write down this one. It is the ratio of the height of the image to the height of the object. But then there is also another formula for magnification, which is M is equal to minus V by U. This is also another formula for magnification. So we have two formulas for magnification. Equation 1, equation 2. Comparing equation 1 and equation 2, what you will get? You will get HI by HO is equal to minus V by U. So comparing 1 and 2, we get, I'll just write it here, we get HI divided by HO is equal to minus V by U. This is another formula which is very, very important again. Okay, we have mirror formula, which is very important. Then this formula is also very important. Equally important are these formulas also. In some numericals, we will be using this, and in most of the numericals, we'll be using this formula. And then, well, mirror formula will be using in every numerical. All right. So, if you have not copied down this, pause the video and copy down, because I'll be erasing it. Okay. So let me move to the side a little bit. Okay. Assuming that you have done, now let me erase this one and let's continue to the next topic. The next one, we'll be discussing about the cases of magnification. So we will still discuss about magnification. Okay, we are still in magnification. So now there are some important cases. Now, first one, M What is this? M less than 1 or M greater than 1? How do we read this? M greater than 1 or M less than 1? Yes, it's M greater than 1, is it not? No. Then is it M less than 1? Yes, this is M less than 1. So if magnification is less than 1, what does it mean? Then M equal to 1. What does it mean if magnification is equal to 1? Then if magnification is greater than 1, what does it mean? So if magnification is greater than, if less than 1, if magnification is less than 1, that means the image is diminished. If magnification is equal to 1, that means the image is of the same size as object. And if magnification is greater than 1, that means the image is enlarged. Okay. Now here I have, let me show this. Let me do like this. Now this is the object. Look at the size of the object and look at the size of the image. Which is bigger, object or image? The image is smaller, the object is bigger. So then image is smaller, isn't it? Okay, image is smaller. So image is smaller, that means it will be, okay, M is less than 1. Since the image is smaller, what do we write? We write the size as diminished. Okay, here we write diminished because it is smaller. So if this is the object and if this is the image, then this will fall under this case. Here magnification is less than 1. If magnification is 1, then you know what? This object, okay, height and this image height will be same. So basically we are talking about somewhat this much, I guess. All right? Yeah. Here the height, the size of the image and the size of the object are same. So this will be M is equal to 1. Okay. And if M is enlarged, if magnification is enlarged, that means the image has to be way bigger. This is the case of M greater than 1. Magnification greater than 1. This is how the ray diagram will look like. This is how the image will be. Okay. The image will be much bigger. Okay. So magnification greater than 1 means the image will be enlarged. This is the picture for M greater than 1. I hope you got it. All right. Now at the same time, if the value of M, okay, if the value of M is positive, if we get positive, then remember the image is virtual plus every virtual images are erect. Then if M value, if we are getting negative, then remember it is real and every real images are inverted. All right. So remember this one, that if M value is positive, then we are getting, then the image is virtually erect. This will tell you about the nature of the image. Okay. The positive sign and the negative sign will tell you about the nature of the image. This one, the magnitude of magnification which you get will tell you about the size, okay, the size of the image. So it tells you two things. The sign will tell you about the nature, which is real or virtual. The value will tell you about the size. Understood? So if M is negative, we will get, if M is negative, that means the image is real and inverted. Okay, don't worry, we will do some questions now to confirm it, okay, to make sure that you understood. So let me do that. So let's take a question. Let's say yeah, take down one question. If M value is given to you as what is it? Yes, minus 1. M is equal to minus 1. I want you to look here. M is equal to minus 1. So M is equal to minus 1. So how do we interpret this? How do we interpret this? See, my dear students, M is equal to minus 1. Nah? There are two things here, okay? There are two things I want you to see. Those two things. The first one is the sign. So this is the sign. Nah? This is the sign. So the sign will tell you some information. Okay? The sign will tell you some information. And the other one is the value. This is the value. So the numerical value will tell you something. Okay? The value. the numerical value will tell you some information. Let's try to understand this. So let's first start with the sign. Okay, the sign. So sign is negative, is not. That means the image is real and inverted. See, so here, okay, here this is a real and inverted image. See, I don't have the ray diagram with me. I don't know where the object is. I don't even know where the image is. I don't know where the focus is. All I have is this value m is equal to -1, and I can tell you so much about. I can tell you about the image. I can tell you about the nature of the image. The nature of the image, which is really inverted. How am I able to tell you? I'm able to tell you because of this. So you have to know this, okay? If you know this, then you can tell about the nature of the image. This negative sign here tells us that the image form is real and inverted. Okay. Then now m is equal to 1. What does this value tell me? This value tells me, so this falls under this, is not. M is equal to 1. See, if the value of m is 1, that means the image is of the same size as the object. So 1, that means image is same size as the object. So this 1 tells me that the image form is of the same size as the object. All right. Did you understand? Okay, we'll do one more question. We'll do one more thing. Let's say now, let's do one more question, like say m is equal to, let's say now minus, let's say, what is the value I took? 0.6. So let's do whatever we did here. So let me put this under box. Now, there are two things here. First, pay attention to the sign. Second, pay attention to the value. So let's first pay attention to the sign. Now let's interpret the sign. Minus now. Minus means what? Minus means it is minus, is not. So it is real and inverted. Okay, it's real and inverted. So sign is minus, so it will be real plus inverted. So the image is a real image, and all real images are inverted. So I know the nature of the image because of the sign. Next is this value. So let's interpret this value. So this value, let's interpret this value. So value is 0.6. 0.6. Where is it? Is it here? Is it here? Is it here? It's definitely not this one. M is 0.6. So how can it be equal to 1? 0.6 is greater than 1 or smaller than 1? Just tell me that. 0.6 is greater than 1 or smaller than 1? It's lesser than 1, is not smaller than 1. That means this one. That means m is smaller than 1. Magnification value 0.6 means m is lesser than 1. That means the size of the image is diminished. So from this I get to know that the image is diminished. See, my dear students, this is the amount of information which we can gather by knowing this and this. So very, very important. These two are very important. Okay, these kind of questions may come in multiple choice questions, so you have to know this. Okay, if you know this and this, you will be able to understand so many things. So this is very, very important. I cannot overemphasize on this, but this is very, very important. All right. Now, one more thing. Now, besides this, with this information, we can even find out the case, which case it falls under. Now you see, this is minus, so the image is real and inverted. Okay, so the image is real and inverted. That means the image is formed below the principal axis. Okay, and the image is diminished. So the image will be smaller. Okay, image is smaller. Then the object will be yes. So this is the mirror. Then where will the object be? If we take concave mirror, well, this has to be concave mirror because we're getting real and inverted. Only concave mirrors will give us a real and inverted image. So we have the image it's really inverted, so it is formed below the principal axis, then plus the image is diminished. So how many cases do we have for diminished? Case 3 gives us same size, case 4 gives us an enlarged image. So after case 3 we get all the images are all big. That means we have to go back. Case 1 the object is infinity, so we cannot. Case 2 the object is kept beyond C. In case 2 the image is diminished or not? Yes, the image is diminished. That means this is case 2. Okay, case 2. How do I know this is case 2? Because of this. The image is really inverted plus the image is diminished. These two conditions, these two information confirms that this is case 2. All right, because go and check out case 2. In case 2 the image is the nature of the image is really inverted and the size is diminished. So this is definitely case 2. So using this information we can even find out which case it is. So see how much information we can gather by this information. Okay, so remember, so this one with the given information I can confirm that means the image has to be drawn. Now this is my focus and this much will be my C, so the image is kept here, and then we know that in this case the image will be formed here between C and F. So the object will be, let me make a little bigger for you so that I can show you that the image is diminished compared to the height of the object. So look here, this is the case. So this is this question, this value confirms that this is case 2. This is case 2. Okay, this is case 2. So like this. Okay, this is very easy. This is how, okay, we can solve it. It's very easy, not very difficult. So okay, let me give you a homework. Here. So let's come back to this one, and this is for you. Okay, you have to give me the answer for this question in the comment box. I want you to comment the answer in the comment box. So my question is, the answer you have to comment in the comment box. Kindly comment the answer in the comment box. And what is my question? My question is to identify this case. Okay, identify this case. So identify this case. Identify the case. So identify the case. This one. Identify the case. Which case it belongs to? It's really inverted plus the size of the image is equal to the size of the object. So the image is of the same size as the object. So easy. Okay, so kindly, okay, identify the case and write and provide the answer in the comment box. Tell me which case is it. All right, so I hope you understood. Okay, so my dear students, this was it. A very important topic, sign convention for mirror. This is very important. So in this topic we have learned about mirror formula, then we have learned about size of the object, size of the image, then we have learned about UVF, and finally this is very important. This is very important. Okay, so this is very important. Take a screenshot of it and then study. Okay, this is very important. So this is very important. This is very important, and with this you can learn so many things. And using this information, you are going to give me the answer on the comment box. So looking forward to your answer. Okay, so thank you for tuning in, and I'll see you again in the next video. Until then, God bless you all and take good care.